All right, guys. Welcome to the second part of Unit 5, Troubleshooting and Performance Optimization. This is a cover troubleshooting mostly for, networks. I believe I talked about that in there. Real-life troubleshooting on a computer also applies to virtual machines. They're about the same as, a virtual machine being something you physically can't touch other than with the mouse and a keyboard. So, I mean, most of the things go hand in hand, but for example, when a virtual machine tells you, oh, it's an issue with the graphic card, you're like, buddy, that's not a real graphic card. That's one that's being emulated. So you have to look at settings and stuff, but I digress. So let's get into it. So here's what we're going to cover: troubleshooting methodology, performance monitoring and analysis, network directory and virtualization troubleshooting, and virtualization specific troubleshooting. So yeah, I should delete that from there, but whatever. That's what the book said I had to go, or that's what I had to cover my outline. So it is what it is, right? So what is troubleshooting? I'll argue this is probably one of the more, I would say, critical units for the course because you're going to troubleshoot your entire life, not just the computers in life. You need to figure things out. It's problem solving, essentially, is the way I look at it. And for those of you that have worked up with me a little bit here and there, because you were having issues with virtual machines or whatnot, maybe another class or another class taking with me, you've seen all the troubleshooting steps we take and we do them, like this. And I'm not trying to say I'm the best or because, it's ingrained into me for doing this for so long. It's just one of those things. It's a skill. Don't feel bad if it takes you a while to figure something out. Troubleshooting is a process. Eventually you will get faster at it. For example, people at work tell me, oh, we're having this problem with the network, this and that. I'm like, oh, it's maybe this or this, off the top of my head. And 9 times out of 10, it's usually one of the three items I mentioned. It's just normally it's DNS. That's the best way I can say it. We have issues with DNS from time to time. So usually the culprit is DNS. Anyways, troubleshooting is a systematic approach to problem solving that is often used to find and correct issues with complex machines, electronics, computers, and software systems, also for cars. Keep that in mind. The first step in most troubleshooting methods is gathering information on the issue, such as an undesired behavior or a lack of expedited functionality. So, yeah, the first thing about any kind of issue you run into, be it someone tells you or you discover, is okay, what's causing it? Why is it doing this? That's the whole reason you're doing this, trying to figure it out. And you need information back. Well, I once had he told me, oh, my Windows XP mouse isn't working. It's like, what do you mean your Windows XP mouse isn't working? Well, what's a Windows XP mouse? Oh, well, we don't have Windows XP mice. We have mice, right? And well, make a long story short, we want to asking her over the phone, like, is it a square? I even made the shape, and I know she couldn't see it. Is it a square plug, a round plug with pins? It's called a, Jesus, it's not cereal. It's called oh my god, a PS2 port. God, it's probably older than half of you in the class and don't even know what I'm talking about. But some of you will know, like, oh, PS2 port, that takes me back. And it's what they use for connectors back in the day for keyboards and mice. And then we migrated to USB. She's like, oh, whatever. I go check it out. Well, what ended up happening was the reason the mouse wasn't working was because it was plugged into the wrong port. She somehow forced a USB port plug into a network connector, and to spare her the shame of making her feel dumb, for lack of a choice word, I told her, hey, it was just plugged in the wrong spot. That's a little, I just left it vague and moved it, plugged it in, and it worked. And that was the end of it. And the whole reason she said it wasn't the Windows XP mouse is someone slapped the Windows XP sticker on it. So hey, the more you know, but that's troubleshooting. So why wouldn't it be working? Why? It could be this, it could be bad, it could be bad plug, it could be kinked wire, anything. Ripped wire, cut wire. The first step in most troubleshooting methods is gathering information. When I mentioned that already. Troubleshooting methodologies usually try to isolate a problem so that it can be examined. You need information to find out what you're trying to do and why it isn't doing it. You try to just go through a checklist of things in your head. Eventually, you become second nature. You're like, okay, it could be this, it could be that, it could be this, it could be that. Things that you run into all the time. So for those of you going on into industry, you're gonna get way better at troubleshooting. I might make up some scenarios for you to troubleshoot as a assignment for this week because I can't exactly break your virtual machines right. So I'll have to think of something. It's Thursday when I'm recording this, so I still have 2 days. So we'll be fine. If need be, I'll take an extra day on Sunday and extend the labs by a day and a half if I have to. It's not that big of a deal. The initial goal is to diagnose the problem and try the obvious solutions, such as performing a system reboot, powering down and up, restarting it was the same thing as power down up technically, but and checking that the power cord is connected. Yeah, I always start with power because power is the most common thing, right? That's what it needs. Any computer, any machine technically needs power. So how does troubleshooting work? Computer problems that troubleshooters address can show up in any number of places. Example of places troubleshooters find themselves working include the following: operating systems. Microsoft can be buggy and weird at times. Applications, Word won't load. Office doesn't load right. My screen is tilted incorrectly for some weird reason in the window, but it looks normal everywhere else. My screen turned purple. That's another one I've seen. CPUs, you can find issues with CPUs sometimes, but those are pretty rare now. You could have where CPUs are damaged and they will throw a bunch of weird error codes, and you eventually figure out it's a CPU. It could be overheating or hardware issues essentially. Down the line, RAM can go bad. That happens too. Firewalls, hard drives, which are kind of being migrated now towards solid state drives. Hybrid drives are technically dead at this point. Servers, bigger, fancier computer, right? Just do more things than a regular one does. I'll probably add hardware to that list. Well, it's technically in there as different items. But anyway, IT and help desk professionals use more extensive ways to troubleshoot problems. Troubleshooting methodologies vary, but the following 7 steps, there's going to be 7 steps after all this, right? Are often used. So you gather info. It's the first steps. You find out, well, hey, what's going on? What's the problem? Tell me in your own words. And here's where I also have to add in a little sprinkle of why customer service is important in the field. You're going to be dealing with people who are upset and angry. So if they tell you, oh, well, it's not working, stupid machine, blah, 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 I can't get it to print. And you're like, okay. So from where you're telling me, I hear you. You reiterate the problem to them, just, slow down. Like, okay, so you're saying it's not printing. Okay, so let's take a root cause. Take a root look at it, a hard root cause, and let's try and determine what's going on. Let me take a peek. If you reiterate the problem to the person telling you, they subconsciously, believe it or not, realize that, hey, this person is actually listening to me. They're going to try to help me. And then they calm down a little. So just keep that in mind. The first troubleshooting step for just about any problem is gathering information about it. This could be information about why something unexpected is happening or a missing capability. What's a good missing capability I've seen? My keyboard stopped responding. Could be unplugged, could be a loose plug, keyboard could have gone bad. A couple things, it could be filters. That's from the Windows 98 days. You had delete filters and registry. I'm not going to get into it. Other important information includes related symptoms and unique circumstances that must happen to reproduce the issue. So you always try to recreate the issue so you can see physically what it's doing. That's why we do it. The goal is to identify the problem and understand how to reproduce it. And I just stated that. So moving on to step 2. Describe the problem. By comprehensively describing the issue, troubleshooters will know where to look for the root cause. It can help to ask the following questions. What are the symptoms? When does the problem occur? Where does the problem occur? Where it's usually on a PC, right? What are the conditions when the problem occurs? Like, what are you doing when it happens? Is the question. Like, are you trying to read? Are you trying to load something? Is Chrome being facetious and taking all the RAM for itself? Is a problem reproducible? So you can try to recreate it. That's what you try to also have them do. Is like, show me the steps you take. And sometimes in the step process they try to do, you find the error. For example, a big one I deal with is with PDFs. People go, oh, I can't see the markups I wrote. And then, all right, well, show me what you're trying to do. File, print, form. Then under the form settings, they have it to show only item, not documented markups. Ta-da, they toggle that by accident, and that solves the issue. But again, that's something you guys will learn over time. So step 3, determine the most probable cause. Sometimes a problem can have many possible causes. That is true. A trial and error method is used to eliminate various options. The best approach is to look for the most straightforward cause first, even when working with a complex system. In other words, always start with the basics. 9 times out of 10, the most basic thing could be causing the issue, and that usually solves the problem. There is the rare time you'll have 1 out of 10 where it's something really so complex and really weird that you'll have to spend a day or 2 researching it. Because let's face it, guys, we don't know everything. We're human. Last time I checked. So one common testament is the split half troubleshooting approach. This technique isolates the source of a problem through a process of elimination. This method works best when the system involves a number of parts in series, a bunch of moving items essentially. So step 4, create a plan of action and test a solution. Once the problem is understood, troubleshooters develop a plan to tackle the issue. They test their hypothesis and keep testing it until they identify a solution. When all tests fail, go back to step 3 and start over. Pretty straightforward. Step 5, implement the solution. Once troubleshooters have identified and understood the problem, they must adjust, repair, or replace whatever is causing the issue. When that is done, they should test the solution to be sure the problem is fixed. The goal is to return the system to the way it was before the problem occurred. Normally, when you implement a solution, you are like 99.9% sure, and then if you do it and it doesn't work, you're like, oh, okay, crap, let me try something else. So that's kind of how that goes. Personally, for me, power supplies are the one thing we just don't swap them out because they're under warranty on our end from HP, so they just send somebody out to do it. And I mean, we can do it, but it's like, all right, we got on-site service, so let them take care of it. It is what it is. And then you analyze the results. Sometimes the solution to a problem create another issue. Troubleshooters must monitor the system to ensure the changes made don't adversely affect other parts of it or other systems connected to it. And then you document the process. Normally you get what's called a work order. You probably see me pull up a ticket remotely, and that's essentially the work order. It's assigned to you. You put your method. Hey, I tried this till it fixed it. Cool. There's mark is resolved, and that's what the documentation is. So in the future, someone says, "Oh, I ran into this issue. Oh, so and so had that issue a while ago, and so helped them. Let me look up their history and who they helped them and was. And here's what they did. Give it a try. Give it a try. It fixes it. Cool." Final step is to document all steps taken. This ensures other troubleshooters will know what to do if the problem's happening. And I literally just said that in my own weird way. It's critical to document both the solution and the fixes that didn't work to provide a comprehensive record of the incident. Documentation will also help in creating troubleshooting checklists to quickly identify and fix potential problems. Again, it all becomes second nature to you guys eventually for troubleshooting. Don't worry, you won't get it right away. I understand it can be frustrating, but the more you say, like, "Oh, I've seen this before. Oh, you know what's similar to this." You have some different avenues of approach when it comes to fixing and solving things virtually or physically. And if you're looking through all these slides by yourself, and then now I chose random for everything, so I don't know what it's going to do. Here's a giant troubleshooting process matrixy, essentially. Start, become aware of the problem, malfunction. I'll let you guys read it. I'm not going to read it out loud because it just, it's like an engineering diagram flow chart, essentially. That's what I was looking for, flow chart. And it tells you essentially the same things I just told you in the steps back there, but there's a little more nuanced. If you're curious, read through it. Don't worry. Question for this will not be on the midterm. Says, draw me a flow chart for trouble. No, I'm not going to do that. I guarantee you I wouldn't do that. That's even too evil for me. So let's get to performance monitoring and analysis. So performance monitoring, the goal of performance monitoring is to maximize system performance by making small changes while maintaining data availability. Performance monitoring assumes that you are using a given configuration that you cannot easily or often reconfigure. So if it's like a bank of servers that can't be brought down, randomly because they host a bunch of data that's needed throughout the day or people access it 24/7, that's kind of where that would come to play. Versus performance analysis, on the other hand, aims to maximize system throughput or minimize latency by trying out various configurations until the best performance is achieved. You're trying to find the sweet spot. So you probably heard in the past, for those of you that work on cars, tune your car, even carburetors, throttle the carburetor a little more, twist the screw a certain way, it gives a little more air, get more power. That's kind of what you're doing. You're tinkering is the best way I can describe it. So if you have a system that you're dividing up between, let's say, 4 people, let's say it's a server, right? It's got 32 gigs of RAM. Like, okay, well, if I had 32 by 4, I can give them about 8 gigs of RAM each. All right, cool. It's a terabyte of hard drive space, hypothetically. And Windows takes about 40 gigs. So you have about 920 gigs to work with. So you can give everyone like about 200 gigs with 125 gigs of headroom here and there. You can allocate randomly. Like, that's kind of what I mean by tinkering. You would test the setup out. You would, virtually implement it on the spare server you have for testing, and have test user 1, test user 3, test user 4, run it for like a week and put it under workload, see if it holds up. If not, where is it chugging? It slows down is what I call chugging. Like like, oh, the system's starting to buffer. You see like a bunch of the same Windows puff populating is what I'm saying on screen. Like, it looks all wavy. That's what I'm talking about. Some of you know what I'm talking about. Some of you will be like, what the hell is he mentioning? The Windows 98 days, if you didn't have enough memory, virtual memory in your machine, where you would, what's called the paging file for Windows. If you didn't have it big enough, you only had megs of RAM back in the day, not gigs. Okay, gigs didn't come out to like around the year 2000, and Windows 98 couldn't support, I think, up to a gig or 2 gigs. Anywho, doing that was like life changing. Back when megabytes were gigabytes to us, and gigabytes then became standard, and gigabytes evolved into petabytes and whatever. Just give you an example. Like I said before, like having more memories, like having more lanes in a freeway during rush hour. So you try to just adjust it. You test it under workload. If it doesn't stutter, it doesn't act up, it doesn't behave differently, then after a week it's good. Deploy it. So going back to what I was mentioning for the unit, I backtrack into the past because I'm trying to make you guys understand things have changed a lot. And somebody will be like, yeah, I remember those days. I was gonna be like, dude, I was born after all that. So this is all new to me. It's weird. It's the before times, right? This requires a different methodology and set of tools to cover such tasks as device configuration, file system management, data collection, test load generation. I just mentioned that, and the like. So you're just doing a bunch of testing, poking, prodding, and making sure it works all fine with performance analysis. So monitoring, you just keep an eye on it. Analysis, you're like, all right, let's tinker and see if we can get this to go better or work worse or whatnot. So, oh, did I have the same one again twice? I do. Let me fix this right now. Okay, I guess I had that slide 3 times. Why? I don't know. I probably cloned it because I was just making other slides after it. I get lazy to retype the title. What can I tell you? It's a bunch of work for me some days. Bring up my tool set. Okay, so on to the next one. So performance monitoring has continued. What to monitor? So what are you checking? Ensure high uptime and peak performance of guest virtual machines. Well, what's uptime? Availability. How long are they up for? When can they use them? And peak performance is, well, when are they running at 100% where they don't have issues? You got to check it out. Like if there's more than one people, duh, it's more than people's multiple, right? It's more than like 5 users, let's say, per these 4 virtual machines you made. So that's 20 users. Can they handle it? I don't know. You got to test all this. But you can monitor, oh, I'm trying it with 10, still okay. I bumped it up 12, it's starting to get a little slow, still okay. I did 15, no, we can handle 15, we can't do 20. So available health and CPU usage. Monitor virtual machine performance. Monitor, I should say monitoring. I'll fix it. Including current availability and health status of the virtual machines. Troubleshoot problems through the root cause analysis window. Know what portion of the virtual machine server CPU is being used by each virtual machine. You can set by core. That's why when you guys configured it, that's what you were doing. And which virtual machine is consuming more CPU. Some are doing a lot more heavy loads like data processing. They'll probably use more CPU than anything else. Also identify the hardware details of the virtual machine server through hardware monitoring and minimize server downtimes caused due to a faulty hardware component. I mean, things fry, guys. Things break, right? It's not like these computers, even like, knock on wood, I guess compressed wood will work, right? In this case, personally, mine hasn't crapped out because I've been lucky, and I didn't use it for like a year and a half when I wasn't living at home. But till then, I'll get whatever I can out of it, and we're great. But other times, you get a faulty RAM stick, you get a faulty SSD with bad chips, you can have a video card just melt in the middle of the day because it just goes bad, or the hard drives can die. That's where replication comes into play and all that. But you gotta expect the unexpected in this kind of business. So here's what a performance monitor looks like. This is something simple. It's just this is the Microsoft one they use right now with Azure. It's what it looks like. It's pretty straightforward for virtual machines. I don't have an Azure license, so we didn't do anything with Azure, unfortunately. But we'll see what they tell me in the future. We can do it or not. So we'll go from there. So let's talk about monitoring more. So what to monitor? Memory utilization, available health and CPU usage. Avoid the problem where your virtual machine running out of memory. Get notified when the memory usage is high or memory becomes low. Metrics include consumed memory, active memory, overhead memory, shared memory, granted memory, reserved memory. I know it's a lot. Here's what that looks like. It's a graph. It's boring as hell, but it's also the Microsoft one. So you can see how much is consumed right here. We're at 90,000 megabytes. So that's like, what, 9 gigabytes off the top of my head? Because that would be 10 gigs, drop a 0. And it rounds and goes up 1. So that's 1 gig. Kernel memory, it looks flat. Sorry, my phone went off. Not important. Gated memory, it gives you all the stats here that it covers. But balloon memory is pretty low. That's fine. Consume memory, it's hard to tell. Oh, that's dark green. It's shared memory, maybe. I'm not sure. Graph's a little weird, but you also have the numbers at the bottom, so you don't have to keep guessing. So Microsoft stuff. It's interesting. So what else are we going to monitor? Top virtual machines. What do you mean top virtual machines? Like the most, which ones are going to be in the hog? Which ones are using the most of what? Get an overview of the virtual machines that are consuming your resources and take necessary action with, I got to delete the ARM stuff. It's from something I had to Google and figure out for you guys. Metrics probably include top. It's all different. It's from a different brand, but this is what it looks like. So it gives you a spit out of this. Let me go edit that slide. Give me 1 second. All right, fix that slide. So on to the next one. So this will tell you what's using the most. So you look at performance here. This is from Microsoft, from Azure's the new Azure cloud. Damn, what's it called? The new Azure VM interface is what it is. Let's try to remember the name. See, performance, top virtual list view, availability. So that's all there. So it's all centralized now, which is kind of cool. But let's get into network troubleshooting a little bit here. Moving on from it, So let me pause this real quick. So I'm gonna be right. All right. So network system directory systems. Directory and virtualization troubleshooting. Network troubleshooting. Network troubleshooting is the process of measuring, identifying, and resolving network-related issues. It's also defined as a logical process network engineers follow to improve the overall network operation. Remember how I had you guys do stuff with me with networking? This was kind of why. Because I talk about networking, so you can see you played with it. So how would you try to solve some of the stuff you created, like the hubs or the links going back and forth, things like that? Troubleshooting for networks, to be honest, is complicated, not because it's so over the top in the sense of, well, it's a bunch of wires. Cool. What wire does what? I don't freaking know, man. I need what's called a tuner. I need I need a link runner to test it, to figure out what the IP is. Like, it's this whole scheme, guys. It's insane. That's why troubleshooting is pretty hard for networking. But if you learn how to do it and learn how to do it well, make very good money as well. Troubleshooting is a repetitive, rigorous, and effective process that involves regular analysis and testing of individual network components to ensure smooth operations. Why is network troubleshooting important? Network troubleshooting is important as it helps IT managers understand network component issues, reduce downtime, and improve network quality of service for users. With an effective, reliable network monitoring system, it's easier to troubleshoot issues, identify network slowdown, quickly analyze latency metrics, so lag metrics. Latency is always lag related. It's how bad you lag. Trace packets and more. Besides troubleshooting, network monitoring systems also help manage network configurations and monitor critical or crucial. The word works. Metrics such as packet data and capacity to ensure smooth business critical operations. Sorry, guys, tongue was a little tight. So, more of the networking troubleshooting continued. Common causes of network problems. There are several reasons why network issues arise, such as sudden spike in network bandwidth usage, so a bunch of people logging on, security breaches, bad actors, faulty hardware. You can have a switch frying, it just crashes, or a firewall crashing that can't handle the load, just restarts. Remember, any computer that restarts itself 9 times out of 10 is doing it because of heat. Why I'm saying that is because computers try to save themselves, and their default program, be it if I'm overheating, restart till I cool off. Happens with switches, happens with routers, happens with firewall. It's just a fault they have built in. So technically everything's a computer, right? So I guarantee if your phone gets too hot, it'll warn you saying we're too hot, let me cool down, or let me restart or power off for a bit. It's just trying to save itself from burning out. And then in-app configuration changes. Sorry. Outlined below are a few reasons for network issues. High bandwidth, like I mentioned. High bandwidth helps transfer data between devices over the internet faster. Downloading large files, shared folders, and video content creates congestion in the network due to high bandwidth usage. This leads to network slowdown issues, network throttling. So for those of you that have cable internet, how many of you have noticed when you get home like around 3, 4, or 5, roughly in the early evening, you log in, you try to watch a YouTube video, it's like buffering longer, or it takes forever to load something. That's why, because everyone's getting home and starting to use up more of the available network. Not just you, but like everyone around you that has the same provider. So that's why I mentioned that. It's an example of it as well. Faulty hardware. One of the most common network performance issues is the malfunctioning of routers, switches, cables, and more. Cables do go bad, switches go bad, routers, they all go bad eventually. I'm not saying they're going to go bad tomorrow, it's over time to degrade. Heat is the enemy of all items. All devices in the network must be configured correctly and tested regularly to ensure the smooth functioning of the network. Yeah. High CPU utilization, usage. CPU usage increases drastically when a large number of network packets are received and sent throughout the network. A huge amount of traffic also overloads the network and requires high CPU utilization to execute these requests. Yeah. Poor physical connectivity. It's crucial to test all cables, so defective cables can generate errors as they're linked directly to the interface of the network equipment. Cable damage can also lead to packet loss and the reduction of the amount of data flowing. Let's move on here. So, directory troubleshooting. The network infrastructure of many companies depends heavily on Microsoft Active Directory. Those of you that install AD know exactly what I'm talking about. Most of you at this point. It offers centralized authentication, permission, and access management for user computers and network resources. However, AD may encounter problems that affect its speed and availability, just like any software system. Yeah, AD can have issues. Active Directory is the authentication and directory service that is provided by one or more servers. Each of these servers is a domain controller. An Active Directory domain is a collection of objects within a Microsoft Active Directory network. An object can be a single user or a group, or it can be a hardware component, printer, PC. Each domain holds a database containing object identity information. So each item holds information, right? You can create users in it, same thing. An Active Directory forest is the topmost logical container in Active Directory configuration that contains domains, users, computers, and group policies, GPs or GPOs. That's what we call group policies, so if you're curious. So here are the common problems, how to troubleshoot them. I mentioned it briefly, how to fix them. It's not exactly cut and dry with this stuff sometimes. Replication. So it replicates itself. It's a crucial function in Active Directory when it comes to one or more domains or domain controllers, regardless of whether they belong to the same site or to different ones. Active Directory replication keeps changes synchronized with other domain controllers in Active Directory forest. So how would you fix that? You would have to roll back to an earlier version before a change is made. That's essentially it for that thing. Because you don't want to burn your Active Directory and rebuild it all the way from the ground up. That would take forever and it's expensive. Replication must occur on the local site as well as additional sites, so that all corresponding domains of forest data remain the same across every one of the domain groups. So when you log in and create a file, it's not much big of an issue for AD. But when you log in and make a change to, I'm trying to think of something in AD, like you had a printer of AD, So it's got to take that information like, oh, this user account in the forest added it. Let me replicate that to myself and replicate it out to every other server that is on this domain that needs to see this. That's what it means. So moving on. Healthy replication in AD force is crucial for its underpinning function, uninterrupted function. Without this, the changes made in one domain controller are not passed through all other domains. Lovely what I just essentially said. This can lead to all kinds of problems, including authentication failures and issues accessing network resources, files, parents. AA won't know what to do with it because they're like, well, this one has it, but that one doesn't, but this one has it, and that one doesn't have it because it shouldn't. So I'm not going to let it log in. It'll be weird. Replication issues may not appear immediately. Therefore, failure to monitor replication, at least periodically, may result in serious issues at very inconvenient critical times. An AD monitoring tool helps by keeping tabs on the status of AD replication and detection errors, as well as other common AD replication issues. So that's now, I think, part of Microsoft's Azure package too. They can monitor that for you. The reason I'm saying Microsoft is the most common thing used. I'm not talking about Apple. I'm not talking about Linux. That's different animal in the sense of it doesn't really play well with AD, but I'm not going to get into it because you can bind them to AD through an old protocol, which it's pain in the butt. But anywho, yeah, so that's where we're at. Here's another common one you're going to deal with. I deal with this all the time. User account lockouts. Most organizations have or should have an account lockout strategy. For us, 3 bad attempts are locked out. This is a security measure that is specifically designed to prevent unauthorized third parties from trying to guess passwords. Account lockout policies can be implemented using Active Directory. Trying the wrong password repeatedly results in the account becoming unusable to an administrator. I said ambassador. I'm sorry. Administrator reactivates it manually. You've got to right click and unlock or reset password. Sometimes account lockouts can happen for no apparent reason. Even if a system admin changes the password, the account may get locked out again very soon thereafter. This can be extremely frustrating for both user and administrator. I mean, you can keep entering your password wrong all day long and it locks it. It happens. Often the problem is exacerbated by an unknown origin of lockouts. Such lockouts would happen when an automated script or process is configured to use a user account for performing a task, i.e. back example given, backing up a file. And if the script has not been updated with the latest password, the account can be locked out. Yeah, that can happen if you have a script running on your PC that you have it log in to only one profile. And if that password for the profile changes, you don't update the script, it's just going to keep going in a loop till it locks itself out. So yeah, that would happen, which I have seen once or twice. So group policies is GP. GP, or group policy, is an incredibly beneficial tool for system administrators, which allows them to centrally configure and deploy just about everything and anything in their Active Directory environment. For deploying software to configuring the default printer for a system, group policies address them all. However, bigger organizations may have many group policy rules and exceptions, and this can make it difficult for system administrators to keep track of everything. The GPOs can get very, very, very deep and complex. Long as this could happen if group policies are incorrectly set, and administrators must determine which group policy is causing slowness. That's how you fix it. You got to figure out which one's causing it. Some common group policy issues in Active Directory environment include group policies not being applied as expected. I see that a lot. With new machines, they get put into a different group, then we got to move them manually to a different group, then the group policies are pushed a day out roughly after. But if you ever want to do a policy update for a machine, you GP update /force. I'm gonna show it to you over here. This is just me segueing out of it. So this kind of applies to that, and or that's too. Sometimes it just overrides the first two, I'd argue. You do this command, and you hit enter, and then give it a minute, and it'll spit back. Yeah, see, then you're done restarting the computer. So that applies for the first two. That's how you fix it. Loops in group policy causing slowness during processing. I haven't seen loops. What I have seen is where there's so many group policies, it takes forever to pull everything and it's slow. So that usually happens. Group policies that have not been updated when the infrastructure has changed, i.e. policy that tries to mount a drive that no longer exists. Yeah, I've seen that. You just have to go and delete it through the server, then push out that command through the network to every available node or machine. Slow network links resulting in some group policies not being applied. That's not too common anymore. Odd folder redirections, only if the pathing has changed, but the outside link hasn't changed, it's caching to the old one, which doesn't know where to go. So it might point to the updated one without telling you. You're like, wait a minute, this looks weird. That happens. You would just have to go back and do a GP update fixes half the stuff if you make changes. Why? Don't ask me, man. It's just how Microsoft has it set up. I don't do this half the time. It's just it is what it is. Monitoring group policy activities and events is a must to know when and how they are executed, and if there are any delays or failures. Changes to group policy should also be tracked, and any performance impact of these changes should be detected earlier to resolve any issues in the group policies. Normally, group policies, when you implement a new one, it takes about like 15 minutes or 30 minutes for it to be picked up. So it's not like you flip on a light switch and it's instant. No, it takes a bit. So sometimes you don't see the change right away. So let's get into the next issue. You see it for network troubleshooting. 1 second, guys. All right, so DNS and DHCP issues. DHCP and DNS are DNS are two of the most essential services in all IT networks. The DHCP server is responsible for managing IP addresses that are dynamically issued to servers and clients to enable them to communicate. When monitoring DHCP services, track the number of IP addresses in use so you can determine when you may probably run out of IP addresses to allocate. That can happen. You run out. Well, what do you do when you run out? You have to spin up a whole new set of IP addresses and make it big enough. It's called a range. You make it as big as possible that you can support with that server. DNS services ensure that the server's client and the services can be found by name. Those who deal with Active Directory are well aware of the critical role that DNS plays in such configurations. In fact, all service providers of Microsoft indicate 70% of all Active Directory issues are DNS related. So DNS just transfers the IP to a name and the name to an IP back and forth, which I mentioned, I think, way back in the beginning of this unit or beginning of class in networking basics. So issues that you run into with DNS and DHCP. Some of the most common DNS issues faced by sysadmins include improper forwarder configuration, incorrect DNS name registration, improper delegation of Active Directory domain name DNS domains, incoherence between domain controllers, global catalogs, and the DNS, incoherence in the AD site infrastructure. DNS and DHCP services are so fundamental to any network that continuously monitoring of their availability and performance is extremely important. So you have network admins for though. So give me 1 second, guys. I know I keep pausing today, just have a lot going on. Okay, I am expecting a phone call, so I thought my phone went off, but guess not. Let me reply to this real quick. Yes. Sorry, guys. I know, just a bad habit of mine, but I'm popular today, I guess. Anywho, Active Directory was designed as a multi-master enabled database. The great advantage is that changes are possible on every domain controller. It is also possible to transfer roles to any domain controller because an Active Directory role is not bound to a single domain controller. It is referred to as a flexible single master operation. And now I have that phone call to take a simple operation role. Give me 1 second, guys. I'll be back after this phone call. All right, took my phone call. So let's do it. Currently in Windows, there are 5 FSMO roles: Schema Master, Master Domain Name, RID Master, PDC Emulator, and Infrastructure Master. Don't worry, I'm not going to quiz you on this in the final either. That's just so you know. I'm not going to go into detail about the roles. I'm sorry. Some of the most common SMO-related problems that system admins encounter on a regular basis have to do with the seizing of roles. So if no one takes the role, transfer roles, like this person's not doing this. Yeah, losing the roles, like you no longer have that role. It is important to track which domain controller is performing a specific FSMO role and at what time. Pretty straightforward stuff. So login failures. Difference from lockouts. Login failures are a common issue in any AD infrastructure. When mistyping passwords or forgotten passwords can cause login failures, the main issue that administrators are concerned about is unauthorized attempts to log into the network by malicious users. When there are repetitive, incorrect password attempts, it is a sign of a cybersecurity breach. Yeah, kind of, or just people sometimes, yes. I don't know how often, but I'd argue yes most of the time. Sometimes some people change their password and forget, believe it or not, and keep punching in the old one, and they get frustrated, and they keep punching in the old one, and then it locks them out. So that's also a login failure. Yeah, statement's kind of wishy-washy to me. But one way to guard against hacking is to consistently keep monitoring consecutive unsuccessful login attempts. So what we can monitor the IP from when they're logging in, and the name they're using, and the password they're using. I don't remember the name of the software. It's like SolarWinds something or other. I'm not allowed to touch it, but I know what it does. And we've had it where people try to pretend they're somebody and they're logging in from like South Africa. I'm like, call the person, hey, Bob from Teaching biology. Are you currently in South Africa? No, yeah, I didn't think so because you're talking to me on the phone. Um, you're in your office? Yeah, so it doesn't make sense why you're trying to log in from South Africa. So that's how we would know. So that's, things like that. On Windows systems, this is done by paying attention to the security event log. Yeah, we have that, but we have a mod that, tracks all that in domain, which is part of AD. So Active Directory database issues. The first thing that comes to mind when someone thinks, or when one thinks of word database is a software like Microsoft SQL, MySQL, SQL, Oracle, or such, other options. An Active Directory database, however, is very different in that it uses a extensible storage engine, ESE, which is an ISAM, indexed and sequential access method database. That is a mouthful, guys. I'm thankful I got it on the first try. Such databases employ a record-oriented database architecture that provides extremely fast access to records. ESE works by indexing that data, or the data, in the database file. So it prefaces it when it indexes. It kind of creates a Rolodex. If you know what a Rolodex is, then it would roll before we had phone books. Before we had cell phones, we'd go through like names A to A, here's one with A, and go to B, everyone with B, everyone with C, last name, and alphabetical. That's kind of in the sense of how it works. This database file can reach up to 16 terabytes and contain more than 2 billion records. That's a lot of data to process. So each object in Active Directory occupies space in the AD database, ntds.dit. For optimal performance, domain controllers cache Active Directory databases in RAM because access to random access memory data is much faster than accessing data in traditional hard disks or solid state disks. Yeah, RAM's always going to be faster than traditional hard disks or spinning platters, right? And SSDs, which, yeah, they're fast, but not as fast as RAM. When parts of the AD database are not cached in memory, these parts will be much slower than those that are. Keeping the AD databases as small as possible is the key to the performance of the domain controller, especially on hardware that can no longer be updated and on Windows Server installations that are incapable of supporting additional CPUs or RAM, like Windows 2016, for example, isn't like, or Server, sorry, 2016 is now so out of date that I guarantee you can't put like the newest i9 on it or the newest Threadripper or whatever. I guarantee that much. And yeah, you're going to be dead in the water supporting old software that's no longer supported and vulnerable because they don't patch it. So when large Active Directory databases have grown steadily over the years, the addition of new features could result in sudden and unprecedented growth. Storing user photos and BitLocker recovery information in Active Directory without proper planning can lead to the performance of Active Directory quickly. I'm laughing because we don't store photos in Active Directory. We have a separate drive, it's called our H drive, which is our network area storage that we have limited, so you can put folders, whatever you need from work, you can just store it in there. So that's why I'm kind of laughing, like, who would put pictures in Active Directory? Anywho, I mean, some companies do like that. We don't. So it's a little bit of like okay, sure, buddy. Tracking the storage uses of AD database and database connectivity is key to ensure seamless AD or Active Directory operations. Almost done. So let's talk about virtualization-specific troubleshooting. VM sprawl. Oh, what the hell is VM sprawl? Here's the challenge about it, or here's what it is. VM sprawl happens when it's impossible to effectively control and manage all virtual machines. You have like a billion virtual machines everywhere. It's like, oh God, what does what? To a network. This often occurs when different departments within the business set up a virtualized instance, and the growing network becomes more than someone can manage. So you just get overwhelmed. That's essentially what it is. Solutions. Here's how you solve it. To prevent virtualization sprawl, first take an audit of the virtualized machines connected to the network. So what machines are what? Who's with accounting? Who's with research? Who's with marketing? Who's with HR? Who's with reception, et cetera, et cetera, et cetera. Then you'll want to identify VMs that are no longer being used and need to be archived. Oh, accounting shrank to 4 people instead of 12. Let me nuke 8 virtual machines off the face of the server or whatever, or retire them or reassign them or what have you. From there, implement policies that address this thin provisioning so the amount of resources used is much smaller than allocated, which is, this is what I just said. You'll also want to evaluate the naming convention typically. What may have worked initially will need to be updated. While this may seem like there are a lot of steps involved, the good news is managed IT solution providers, MSPs, can assist with the cleanup and management of VM sprawl to not only optimize the virtualized, I should say virtualized systems. I will fix that. I'll fix that right now. Give me a segundo. So the next one, virtualization specific, we're still on virtual machines. Application performance. So here's what it is. Once a business has migrated to a virtualized system, they may find that things are not working as seamlessly as they should. Legacy systems may cause problems with newer virtualized software and programs. Older software may not be compatible with virtualization, or current applications will not be performing even with virtualization. Sorry, I guess I got a Steam notification. A solution will depend on several factors, including the VM setup, and whether there's legacy software or updated software. Run tests to identify any resources being overutilized or work with MSP, a vendor, to look for compatibility issues between software and VMs. Typically, MSPs will be able to locate and pinpoint areas more quickly than someone on an internal IT team who isn't familiar with these types of system conflicts. There may be upgrades or workarounds to get everything functioning as it should. So, bottlenecking. This is probably one of the biggest things I've seen with regular PCs. So what's bottlenecking before I even get into this? Physical bottlenecking on a machine isn't no you physically try to squeeze it into the bottle. No, that's not what that means. Bottlenecking is you reach a point where it just compacts and can't process things fast enough. So let's say you had, let me try to think of an old processor, like a Pentium 4. Let's go really back in time. You slap in the newest graphic card into it, you find a slot that somehow works with it, let's say, yeah, that's going to be bottlenecking because they can't keep up with the processing speed and requests from the CPU or from the GPU. That's bottlenecking, essentially. When users create a high demand of VM resources, bottlenecking will happen. There are various reasons that bottlenecks occur. One of the most common causes is the incorrect configuration of network resources. However, bottlenecks also stem from processing limits, which I'll talk about the GPU part, memory deficiencies, and storage space issues. Like for some of you, I know don't have the most powerful machines. I'm not insulting anybody. It's not the point. But you try to dedicate like 4 gigs out of your 8 gigs of RAM, you're going to have a bad time because now your machine's going like, half the memory is being used. And it's going to start to slow down and stutter. That's where that comes from. I'm not saying you're doing it intentionally. Just it happens. That's why cut that in half to 2 and whatever, what have you, you're fine. In a virtualized environment, these factors interconnect. So changes have a broader impact. Identifying where the bottleneck is occurring and implementing a fix can become very complicated. Solution. Resolving a bottleneck depends on the exact cause. Incorrect network configurations are often the primary reason for bottlenecks. Not really true. It's also configuration. But if you configure it right the first time, you're usually fine. The reason for this is because there are many different areas involved in the setup of a network configurations. It's true. And as a result, there are many steps to troubleshoot specific areas as well as many solutions, which is why MSP is critical to overseeing proper network configurations. Almost done, guys. Last slide before we get to the overview. And the last one is licensing compliance. Well, you gotta pay for licensing, guys. It's not free. Software isn't free. You know what I mean? Pirated software is free. That's different. I'm talking about physical software you're actually gonna buy. Well, physical, digital software you buy and use every day for a company. You're paying for it. Okay. Running licensed software and VMs can create compliance issues. Sorry, but many software license agreements have now incorporated VMs, multiple CPUs, and other resources provisioning tools. Solution: always renew and understand the licensing rules for software and business applications. In most situations, each user application on a VM requires a license. There are challenges associated with virtualizing a network environment and solutions for overcoming them. If your internal IT team isn't equipped or skilled enough to manage a virtualized network, MSP can help you make sure the VM is correctly configured and managed. So here's the thing about licensing. I'll give you a quick example. For us, we pay for Cisco licensing per phone. It's 1 per user, and we pay the licensing fee. Well, if someone gets offboarded, we cancel the license and get some money back. They do that all the time. So Jabber, I'm sure maybe you've heard of it, also requires a license. And they had a rule that if you don't use it within a month, because you just don't use it, we cancel your license. And they'll tell you. So next time you log into Jabber, like, oh, why isn't it working? Why isn't it updating? That's why, because the licensing wasn't updated or paid. So that'll be a compliance issue on our end, or technically yours, but it depends on the user and all that stuff. So that is it, guys. This is the end of Unit 5 lecture. Next week is Unit 6 lecture, the final, maybe a lab or 2, and that's it. I'll say it now, and I'll probably say it again at the beginning of Unit 6. It has been fun having you guys. And I stated before the beginning of this unit, I'm not kicking any of you out from Discord, so we can stay there and bug me all you like. Bug me, just message me or whatever. Be kind. Please be kind and rewind. I'm kidding. You don't know what that means. It's back when we had videotapes. But yeah, just drop me a line, email me. You guys need something? I'll write you a letter or whatnot. Rec, not that big of a deal. So here's what we covered for Unit 5: troubleshooting methodologies, performing monitoring and analysis, networking, directory and virtualization troubleshooting, and virtualization specific troubleshooting. So there you go, guys. Till then, I will catch you in the next one. I will see you in the labs. Take it easy.